So today is August 8th. And we're doing some exponents. You guys have a test coming up. I'm not sure exactly when yet, but it's a test over 0.1, 0.2, and 0.3. And so that's coming soon. Next week sometime, I think. So be prepared for that. I'll let you know the date probably tomorrow. I think we have that information for you. And we're doing some more with exponents. We've done a little bit with exponents. On the first day, I gave you that fun worksheet. Oh, you also might have noticed that I updated some grades. And so, yeah, check your grades because there's, with all the movement of students, so sometimes things get overlooked, like the syllabus signature and that sort of stuff. If you didn't get that signed yet, fine. Print off the last page and get it signed and bring it in. It'll be perfect. That's fine. If you're missing any work, I'll take it. Get it to me and I'll take it. The other thing you want to know, if you got like a 9 out of 20 on class practice 1 and 2, the real reason is probably hanging on the wall of no-name papers. So perhaps you forgot to put your name on it and it's just waiting for you to claim it, okay? And so keep that in mind. But I am human and I make mistakes on grading, mostly typing too fast. I put in, 1 0 enter, but my fingers do 1 enter 0, and so you get like a 1 instead of a 10. And so that happens a lot. And also, I have 175 students, folks. So my eyes go cross-eyed looking at those papers, and I get off a line or something like that. So just know that it's possible I made a mistake. I'm happy to fix it.
I thought that was the first thing. I know for one reason. Done with. So I didn't know which was on the list.
The two. There's not a lot.
I'm not doing it. It's great to have. Yeah, that's good. I already failed. My junior year's going great. It just started at 0. 0 is good. I guess we're
Yesterday. Watch me get another yesterday. I'm gonna laugh with that. I'm like,
not the end of this class.
I know, because you came over to and you're I'm more involved with so like yeah. And then I had
Tomorrow. What?
oh and I wanted to
So I turned 16 like the guy who tweeted.
I was just I
should be
yeah.
So stupid.
Yeah, but probably like he probably does. But he doesn't show it. Yeah. I've been able. This one doesn't have any ports. But that's how he's in general. Yeah.
Okay, sorry about that. So we did a little bit with exponents. And so just to refresh our brains here, x to the 4th times x to the 7th is x to the 11th. Good. So when they have the same base, you're allowed to add the exponent. If we have x to the 4th raised to the 4th, no, that's a bad example. 7. Sorry, that's what I meant to do. What do you do there? You multiply those powers. So you get x to the 28th. Very good. Okay. So there's a couple other exponent rules that we want to recall. And so if you have, 249 to the 0 power. 1. Anything raised to 0 power is 1, provided it's not 0 to the 0 power. 0 to the 0 power is not something we do. Okay. And let's see, what else? Oh, what is, I don't know, 2 to the negative 1 power?
0.1/2.
Yes. What were you, is it Joyce? Is that right?
Yes.
Yes? Okay. 1/2. It is 1/2. Very good. All right. Negative exponents. Negative exponents are something that, you know, when I started teaching, we didn't teach negative exponents in Algebra 1. I kind of think they do now, but I don't know who your teacher was, or, you know. So I think it's an Algebra 2 topic personally, but they use negative exponents, and we'll see negative exponents, and all the same rules still apply with negative exponents as they do up here. A negative exponent creates, it's a reciprocal, okay? What is a reciprocal? It flips a fraction, yeah? Okay. So here, if you think about this as 2/1, a fraction, the base, it's going to flip that base, take the reciprocal, essentially, and so it becomes 1/2. Some the greatest way to say that. So if I have x to the negative 2nd power, that negative exponent, again, is going to create some sort of fraction. I like to think about it as everything is in this imaginary sort of fraction. Okay. I personally like to think about negative exponents as unhappy in their current position. It's a whole upstairs, downstairs thing. So he is very negative. He's very sad to be up here, this whole thing up in the numerator. He wants to go downstairs. And so when he goes downstairs, oh, now he's nice and positive now. He's nice and happy where he's at. It's totally stupid, right? But that's how I prefer to think of negative and positive exponents. The same is true if you have like x cubed underneath in the denominator, 1/x to the negative 3. X to the negative 3 right now is unhappy in its current location. So what does he want to do? Move up top. Okay. So where he would become now a lovely, positive, happy exponent person. Okay? Now, the same rules still apply. If I have x to the negative 4 and x to the negative 7, they have the same base, and I can still add the exponents just as I was before. So it'd be x to the negative 11. And then I'd want to flip it to the denominator. Okay? So we have positive and negative exponents. Negative exponents create fractions. Okay, good. Now that we all have the same sort of background information, example 1. Evaluate each numerical expression. Evaluate each numerical expression. Now, these are numerical expressions, meaning it's an expression entirely made of numbers. And something entirely made of numbers can entirely be done on your calculators. Oh, what? I know. So they can. Of course, your job is to show the work to get there and use your calculator to check, okay? Chances are, okay, I will never give you a question like this on a test, right? Because I know you can just use your calculator. All right. I will show you how to do that, though, because knowing how to use your calculator is a big part of math these days. Now, I'm going to go ahead and say we have 3 to the negative 2 times 4, all raised to the negative 1 power. Does 4 have an exponent? No?
Yeah.
Yes.
Oh, it's 1. Yeah, everything always has an exponent, and I like to remember that because it's really, really helpful. Now, I have powers raised to yet another power. So what can you do with those powers? Multiply them. Yes, and they sort of get to share. You get to sort of distribute those powers, multiply them all together. So that gives me 3 to what power? With a positive 2. Negative 2 times negative 1 gives you a positive 2. Multiply the powers. Times, now we have 4 to what power? Negative 1. Okay. A good first step there. Now, this is 4 to the negative 1. What should we do with that negative exponent? What's going to happen? It's going to flip. Yes, it's going to flip. That is a fraction. What is that fraction? What's it going to flip into? 1 over 4. Very good. Times the 3 squared. And what is 3 squared? 9. Times 1/4. And what is 9 times 1/4? 9/4. Okay. All right. Now, of course, I show all of my work. Maybe you can do that instead of in 1, 2, 3, 4 steps. Maybe you can do it in 2. That's fine. Okay. Did you check on your calculators? No, not yet. Let's see. So watch this, ladies and gentlemen. I'm going to type it in just like it is. 3 to the negative 2 power times 4, parenthesis, raised to the negative 1. And I get 2.25. Is that the same as 9/4? Yeah. You can also hit math frac. The math button here. The first thing is convert to a fraction. Convert to a fraction. Math frac. Math.
It's like Affleck.
Except we call it math frac. And that's like a 4-letter word in this class. Math frac it. Okay. And you see the 9/4 step. Math frac is an awesome button to have, but I hope you guys are pretty good with fractions. All right. Letter B. Once again, I'm a huge fan of Veronica Mars. Have any of you ever watched Veronica Mars?
Yes.
Yes? Okay. It is a fantastic show. And there's a whole episode, and a big thing about the show is that they don't use the F word ever. Okay? And so there's one whole episode where she's trying to get, you know, the F word to the new slang now is to say, what the frack? And I just think it's funny because I say man frack all the time. It's a great show. All right.
I'm only on season 3, guys.
Okay. I won't spoil anything. It's really good. Okay. Here we go. Once again, we have a power raised to a power. Power raised to a power. What do you do with those powers? Multiply them. Again, share the wealth. You get to multiply those powers together. So we have 5 to what power? 5 to the 4th. Negative 2 times negative 2 is 4. 2 to what power? 2 to the 6th. Good. Does anyone know 5 to the 4th? Okay. Jeez. I'm just checking. Yes, 625.
It's the same as 25.
And then 2 to the 6th? 64. Very good. So remember 5 to the 4th, just in case. 5 times 5 times 5 times 5. And 2 to the 6th. A bunch of 2's there. And again, 8 times 8 would get us to 64. Okay. Questions on those? Can you?
If you rationalize it.
No.
In improper
So you're saying are you asking me can you change it to a mixed number? No, we're not solving. So if it was like x squared equals 625 over 64, if you were solving an equation, for x, then you would take a square root of both sides. Okay, yeah. No, lots of big numbers. Yeah, big numbers are going to happen. So this is not an equation, so we can't do any sort of taking a square root of both sides. That doesn't work. And this, does this giant fraction, does it reduce? Yeah, so how do you, I know because of this. Here we have all these factors of 5. And here we have all these factors of 2. Do they have any common factors? Top and bottom? No. So it's not going to reduce. Okay. All right. Good. Try 2 more. What's the difference between C and D here? Okay. Yes. Adding and subtracting. The first 2 were just a multiplication and division problem. These are adding and subtracting. So, a little different. Addition and subtraction. 4 to the negative 1 plus 2 to the negative 1 is 6 to the negative 2. Is that right? No, it's not. So, what is 4 to the negative 1? 1/4. Plus, what is, 2 to the negative 1 is really 1/2. All right. What do you need in order to add fractions? So I'm going to multiply by 2. That's going to be 1/4 plus 2/4, which is 3/4. Isn't this great? Okay. Last one. I think it's the last one. Yeah, it's the last one. Okay. This is college algebra. Let's just talk about this for a second. Okay. Ladies and gentlemen, I have a question for you. Can I distribute this power? No. Big difference between letter B and this one. And what's that giant difference? Subtraction. You can distribute the powers like we did on letter B. On letter B, that's what it's going to do. When it's multiplication on letter A, just kidding, or division. You cannot do that across addition and subtraction. Addition and subtraction, it turns out, make everything so much harder. All right? The multiplying and dividing, super easy. Addition and subtraction just suck. All right? It never goes easy. So we have to work within our parentheses to get started here. Order of operations here. We have to convert 2 to the negative 2. What does that do? Yeah, it's 1/2 squared, or 1/4. And what is 3 to the negative 2? Yeah, 1/3 squared. That negative exponent flips it down into a fraction, or 1/9. Okay, so now we have 1/4 minus 1/9. I need a common denominator. 36. So times by 9 times by 4. So that's 9/36 minus 4/36. Yeah. Which is 5/36. Now that whole fraction is to a negative 1 power. So you flip it again. So it turns into 36/5. How does that work? So this power, the 5 has its own exponent, right? Yeah. Now it has its own little exponent of 1, and so does 36. So here we have power raised to a power. You can do 5 to the negative 1/36 to the negative 1. This guy's unhappy. He wants to move down below. This guy's unhappy. He wants to move up top, and that's how we get there. Okay? But yes, you get to flip the whole fraction. Adrian.
So what happens if bottom one wants this go down, but top one wants to stay?
That's happens too. So if you saw 5, did you say top or bottom?
The top one's negative, the top one's plus. Or it doesn't, bottom one doesn't have to.
Okay. So let's say it's like this. 5, the question was, how does it work if one wants to switch and the other doesn't? Okay. So right now, 5 has its exponent of -1. And that one is unhappy. He wants to move down. What's left in his place? A 1.
Wait, why?
Why? Okay. So let me back up a step.
Oh,
Are these two things equivalent?
yeah.
Yeah, if you were to multiply them together, you get 5 to the -1 times 1, which is 5 to the -1. And 1 times x squared is x squared, right? So I can now say this one's unhappy and he wants to move down below. And there's always going to be something left there. 1. So 5 to the happy one. And that x squared was perfectly content where he was at, so he doesn't move at all.
So they're getting multiplied, not added.
Correct. Because, right. That is not just you, just in case you were wondering what the reading
It was
was.
there yesterday as well.
Yes, it's annoying. Happens twice a day at 38 on the hour.